One of the most important theorems of algebra is the fundamental theorem of algebra that says that every polynomial function with real coefficients can be uniquely factored into a product of linear factors, factors of the form x minus c, and irreducible quadratic factors. Irreducible means that those cannot be factored. So if I take any polynomial in general form, I know the theorem guarantees that that polynomial can be written as some constant times some linear factors x minus c1, x minus c2 times, let's say, x minus ck, and then some irreducible quadratic factors. So we can have x squared plus p1x plus q times and so on, x squared plus pnmx plus qm. So in that factorization, there are going to be some linear factors and there are going to be some quadratic factors that cannot be factored. Now, theorem says that such factorization exists, but it doesn't say how to find that factorization. And our objective here is to be able to write such factorization for some polynomials. This theorem tells us also that a polynomial of degree n can have at most n real zeros. Now notice that if x minus c1 is a factor in this product, then c1 is a zero of the original polynomial. So we can have at most n factors x minus c in such factorization because the degree of that polynomial is n, and therefore a polynomial of degree n can have at most n real zeros. So once we have a polynomial, we know how many zeros we can expect. Let's look at the example. How many real zeros can the polynomial f of x equals 2x to the 6th minus 18x to the 4th plus x squared minus 9 have? And if you look at this polynomial, the degree of that polynomial is 6, and therefore there are at most 6 zeros for these polynomials.